Hello everyone, welcome to Source's classes. This is Tushar Shaw, and in this video we will be continuing to solve the GATE 2021 CY questions that we were solving since the last 7-8 videos, I guess. Okay, so in this in this video we will be completing the set of the MSQ 1 mark type question with no negative mark. Okay, only one question is left, that is question number 18. So we'll be starting from that, and after that we'll be moving on to the NAT 1 mark type question also having no negative marks. Okay, so that is all about the structure of this video that we'll be going into. So let us without wasting any time, let us look into the questions. So question number 18 says that the normal modes of vibration of H2O is or are. Okay, so normal modes of vibration is being asked. So the options that are given. So let me draw the options for you. So option A has H O H. We have this kind of and this. So I'll be giving description at the end. So let me draw the structures first. So we have this one, we have this one, we have this one. Okay. Then we have H O H. We have this O above and this H is as below. Okay, and option D has H H H. So all the three arrows are up. Okay. So the first option obviously is the exact mode of vibration, mode of like that the question mode of normal mode of vibration, that is symmetrical stretching. Okay, first one is symmetrical stretching which is symmetrical. Okay, the other one, the next option is asymmetrical stretching. Okay, stretching. The next option here is bending modes. Okay, here you can see that this molecule is like elongated towards the edge and but not taken away from O, so this is stretching. This in this case we have this elongation towards one bond and the other bond is getting short, so that is asymmetrical stretching. Here the H is being pulled towards another direction and O is being pulled towards the other direction, making the molecule to bend, and that is one type of vibration. But in the last option you can see that all the three arrows are pointing upward, that is the molecule is going up. So that is not a mode of vibration at all. Okay, it is just the molecule is moving from one place to another using all the three all the three atoms are having the moving vector in the same direction. So the molecule in overall is moving. So that is not a vibration at all. Okay, so that this molecule the structure does not make any sense. Make no sense. Okay, makes no sense. Okay. So in the all the options that are correct are obviously option A, B, C, the only these. Okay, D is obviously incorrect. Okay, so let us move on to the next question. So the next question is obviously now, as I mentioned, question number 18 is finished. So we will be moving from here to the NAT, the numerical answer type question, carrying obviously 1 mark if the question is right, and no negative marking. Okay, no negative marking. This set of question will be continued from question number 19 to question number 25. We did up till 18 up then the last question, so we'll be starting from question number 19 in this case. Okay, so the question number 19 says that the reversible heat engine absorbs Q is equal to 20 kilojoules of heat. Okay, from one source at 500 Kelvin. Okay, at 500 Kelvin, this one is absorbed and dissipates into the reservoir at 400. So this one is the hot reservoir, and this one is the hot reservoir, and the cold reservoir is at 400 Kelvin. Okay, cold reservoir. So the efficiency is being asked, and obviously it is given in dash percentage. Okay, you have to like in these kind of exams you are given a dash, and obviously a unit is already mentioned. You just need to write the value. Okay, so we can solve it in this way. Um, So obviously, so TC. So let us write down the in the exact way. So TC cold reservoir is given 400 Kelvin. TH the hot reservoir is given to be 500 Kelvin. Okay. So efficiency, the formula of efficiency is equal to TH minus TC divided by TH. Okay. This one will be equal to 1 minus TC by TH, which is equal to 1 minus 400 by 500, which is equal to 0, like 1 minus zero point 0.8. This value comes to be equal to zero point 0.2. Okay, now we have to calculate it into percent. So 0.2 into 100 which gives 20%. Okay, so in the chat box, then the box that obviously I expect you might be knowing how to write the answer in the NAT question. So let me explain it to you once again. What happens is you will be like for writing, for filling in the blanks, you will be given a box, like a box will be given with all the numbers typed in, and the minus, plus, and those decimal and those stuffs which are required to write in the question. The answer that will be provided to you. You will be just clicking into the in the correct numbers, and the option will be filled up instantly. Okay, so here will be, you have to write 20 as the correct answer. So you will be clicking on 2 and 0, and then you will be getting the like in the dash you will be seeing that 20 is filled up. Okay, so this is how we attempt the NAT questions, and obviously in this case 20% would be the correct answer. Okay, moving on to the next question. That is question number uh, 20. Okay, now this is a kind of a big question. So 8 structures are given. So let me just write down the explain each and every structure one by one. Okay, so CH3, here O is given, here CH3 is there, and so this structure would be showing a stereoisomer. The question asks that among the 8 compounds, the number of compounds that can show exhibit stereoisomerism. Okay, so this compound is chiral, and this compound is chiral. This carbon is chiral, and this carbon is chiral, and overall the molecule is not chiral. So this is not a meso compound, and hence it will be showing stereochemistry. So this one will be showing stereochemistry. Okay, the next compound that is given is PH, OH, CH, triple bond, CH, OH, PH, CH3. Okay. Here also this carbon and this carbon are like chiral. They will be having the RS comment, RS designation, and therefore would be showing stereochemistry. Okay. Now, uh, in this molecule, let me draw the structure first. So in this molecule, you will be also be showing stereochemistry. This molecule also will be showing stereoisomerism. Why? Because this carbon and this carbon are chiral, so they will be showing the two enantiomers, DL and isomers. So they will be exhibiting stereoisomerism. Okay. Now this molecule, this is a kind of an interesting molecule. So this molecule has no such stereoisomerism, because this molecule obviously, like if you divide in this way, you will be getting the same structure of once and for all. And obviously, like because the molecular plane is passing, this molecule is a meso compound and would be showing no stereochemistry at all. Okay, so this one won't be showing any stereochemistry. Now the next structure is derivative of ferrocene. Okay, and here we have CH, CH, OH, CH3. So obviously this carbon is chiral. Okay, so this would be showing RNS isomers, enantiomers, and therefore would be having exhibiting stereoisomerism. Okay, the next structure is So we have this three aromatic rings. We have a tertiary butyl group over here. We have CH3 over here, and we have this CH3 over here. So this molecule, obviously here is one N. Okay, so this molecule, though it is not exactly chiral, but this molecule is totally planar and totally aromatic. Okay, and no such you can divide this molecule using the molecular plane. Okay, this compound then being a meso compound and would be hence not showing any stereoisomers. Okay, the other two compounds that are given, CHBr. So this is an arene system which comes under the attrop isomerism part. Attrop isomerism part. This would be showing the R star S star designation of that is the enantiomers, and therefore would be showing stereoisomerism. Okay, the structure, the next structure that is given is kind of just given to like confuse your mind. Okay, because obviously in the this structure you can see that methyl groups are like but both of them are in this way. So you can divide this molecule and guess show that this molecule has a sigma plane and therefore wouldn't be having any stereoisomers, but that is not the case. This is a cyclohexane. Okay, and cyclohexane normally exists in, if not given anything, we'll be assuming that this cyclohexane exists in chair form. Okay, so this methyl can exist here or here, and the other methyl also can exist here or here. Okay, so axial and equatorial isomers are already present in the system. Okay, so this oil molecule won't be would be obviously like giving exhibiting stereoisomers. Okay, so this one is also exhibiting. So except for two structures, the other in the other stick structures in all the eight compounds that are given would exhibit stereoisomers. So therefore, the answer in the chat box that you will be writing is 6, exactly 6, and that would fetch you the correct like full marks. Okay. So moving on to the next question. That is question number 21. The question 21 says that the MO-MO bond order in the MO-MO bond order in the complex that is given. So let me write down the complex. Say sigma 5 C5 H5 MO CO2 whole 2 which obeys the 18 electron rule. So this compound obeys the 18 electron rule. Okay, and we need to find out the number of bond between two MO atoms. Okay, so let us firstly like calculate the overall the electron contribution in this complex, and then we'll be calculating. Okay, so sigma 5 Cp sigma 5 eta 5 Cp would be contributing. There are two eta 5 Cp, so one would be contributing 5 electrons. Therefore, two of them would be contributing total of 10 electrons. Okay. MO molybdenum contributes single-handedly contributes 6 electrons, so 2 MOs would be contributing 12. Okay, and CO itself contributes 2. Okay, 2 electrons, but here there are 2 into 2 4 electron 4 CO atoms, so 4 into 2 would be giving 8. Okay, so the total electron contribution from the individual atoms individual ligands in the this complex is given by 10 plus 2 so 10 plus 12 plus 8, which gives 30. Okay, and as the molecule has two metal ions, so 2 into 18 electron rule, which gives 36. So if the molecule needs to follow the 18 electron rule, the whole system, this whole complex must have a total of 36 electrons. Okay, but we have calculated the total electron contribution from the total species to be equal to 30. So the 6 electrons is remaining. These 6 electrons are there bonded in between the two molybdenum atoms. So one bond consists of 2 electrons. So the number of bonds in number of bonds between two MO is between MO MOs are 6 divided by 2, which is equal to 3. So the complex would be having MO triple bond MO. Okay. So in the chat box you will be writing 3 as your correct answer. Okay, 3 will be correct. Okay. So yeah, so that is this question. So in the let us move on to the last question of this video, that is question number 22. Okay, question number 22. So the question number 22 says that the change in enthalpy delta H for the reaction given is 2PS plus 3Br2 3Br2, which is in liquid state, gives 2PBr3, which is in liquid state. We have the delta H value for this reaction is given to be minus 243 kilojoule per mole. Okay, kilojoules. Okay. So in this reaction, the amount of phosphorus consumed is 3.1 gram. So the phosphorus consumed is 3.1 gram. The total amount of phosphorus taken is 3.1 gram. So obviously we have to calculate that amount of enthalpy for this 3.1 gram of phosphorus that is being consumed. Okay. So let us look into the question here. So in this reaction, you can see that for 2 moles of this phosphorus, the overall delta H is tends to minus 243 kilojoule per mole. Okay. Now phosphorus almost has has a weight of 15.5. Okay, yeah, 15.5, 16. We consider it as 16, but it is normally 15.5. So this is the molecular weight. So 2 phosphorus would be having a molecular weight almost tending to 31. Okay, molecular weight would be having 31. So the total number of moles that we have taken is 3.1 divided by 31, which gives to be 0.1 mole of phosphorus. Okay. So yeah, so this is the case. I'm sorry. The overall molecular weight of phosphorus is 31. The molecular this atomic number is 15, but that is not a consideration. The molecular weight of one phosphorus is 31 gram. Okay. So the number of moles taken is, this is the number of moles. Okay. So this is obviously that this delta value is for 2 moles or 2 moles of phosphorus. So 2 moles of phosphorus would give minus 243 kilojoule. Okay, so therefore 1 mole of phosphorus would be giving minus 243 divided by 2 kilojoule, and therefore 0.1 mole of phosphorus that we need to find out, phosphorus will be equal to minus 243 divided by 2 into zero point 0.1 kilojoule. Okay, now this value comes to be let me calculate the value. So this value comes to be minus 12.15 kilojoule. Okay. Yeah. So this value, So this value comes to be minus 0.1 minus 1.12.15 joule. Okay, kilojoule. Now obviously you have to look at the question properly, because they have calculate the value in kilojoule, so you will be keeping your value in kilojoule also, and the question says that the value must be rounded out to 2 decimal places. So even if the value you have got in many decimal places, you will be rounding them off to 2 decimal, that as I have done in that is 1.15. Okay. So in the chat box you will be writing minus 12.15 as your correct answer. Now what would happen is, if you this is a very drastic thing that should not happen to any of the students, that is, even if you calculate the right answer but do not follow the instructions and mismatch the instructions of the decimal that is given in the question, like if you are given 2 decimal, to write in 2 decimal, and you wrote it in the 3 or more decimal, or even rounded up to the nearest integer, though you have made the answer right, you won't be getting any marks for that question. Okay, so that should not happen. I myself have faced this. I have got many marks were deducted from my questions also. So because, and that is why I got a quite less ranking than I had expected. Okay, so yeah, so that is the exact case. So so let us wrap this video up. We did almost 6 questions in this video, so this is a quite a long video that we have compensated for the last video only. Okay, so and then from the next video we'll be solving that the left or left out this MCQ type questions, NAT type questions of the 1 mark section, and then we'll be moving on to the MCQ section of 2 marks question, 2 marks. Okay. So thank you guys for this video. I'll see you guys in the next one.